Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7, want to present Air and Noise Pollution Project. So for task 1, which is MSW incineration. MSW stand for Municipal Solid Waste. This is our team members. First is myself, Ifan Amza bin Sulaimi. Second, Siti Nofitra binti Saidin. Third, Muhammad Rafi bin Jesham. And last, Nur Sabina Fatini binti Muhammad Hafizah.
Because many contaminants are released into the atmosphere during the burning process, waste incineration is another option to reduce it. Homes in Malaysia treat between 17 and 80% of the country's municipal solid waste, which is then dumped in landfills. Because Malaysia cannot rely on landfills, one disposal option being considered is the use of an incinerator. One of the primary goals of waste incineration is to reduce the volume of municipal solid waste. Even while burning rubbish that have its benefits, there are still problems with air pollution, including discharge of heavy metal and particulate matter. Modern equipment and appropriate management techniques are required to address the threats to the environment and public health associated with waste incineration. Alam Flora Sdn Bhd is among the top environmental management firms in Malaysia. Alam Flora Environmental Solutions Sdn Bhd (AFAS), a wholly owned subsidiary of Alam Flora Sdn Bhd, was founded in 2013. Based on Berita Harian newspaper, AFAS has effectively renovated and restored government-owned incineration plant located in Cameron Highland and Pangkor Island. From the Malaysian Reserve News website, it states that AFAS with the capacity to incinerate 40 tons to 20 tons per day. Due to efficient combustion and effective treatment of flue gas emission, the plant dioxin emission is less than 0.1 ng/nm meter cubed, meeting both Malaysian and international regulation. One statement of this project is burning municipal solid waste (MSW) is a practical solution for waste management concern, but it comes with significant air pollution risks. The pollution emitted into the atmosphere when various waste materials are burned in incinerator facilities is a serious environmental issue that has to be addressed immediately and with purpose. Overcoming this challenge requires a comprehensive approach that considers technical advancement, environmental sustainability, economic feasibility, and social fairness. Objective of this project is to analyze advantage and disadvantage of municipal solid waste incineration, to investigate standard regulation measures related to environmental safety air emission, and to purpose air pollution control device related within incineration process. The scope of study of this project is to the study of municipal solid waste incineration encompass a thorough examination of technical, environmental, socio-economic, and policy factors associated with this process. The goal of the study is to provide a comprehensive evaluation of alternative incineration methods, accounting for their efficacy, scalability, and adaptability to diverse waste kinds. To optimize the incineration process, the research will further investigate strategy for trash sorting, sources reduction, and pre-treatment protocols. We will extensively investigate the effectiveness of municipal solid waste incineration regulation frameworks and policies at the local and national levels to determine how effectively they protect public health, safety, and environment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nofitra Binti Saidin, and I will present for the part literature review, which is we have advantages and disadvantages of incineration. First of all, for the advantages, firstly, we can recycle the heat energy to generate renewable electricity. Second, can reduce the volume of the solid waste to 10% of the original size. Third, can lengthen the life of landfill. Next, can decompose the part of the toxic materials into carbon dioxide. And we can also limit the space use. For the advantages, we can release toxic materials and carcinogen, especially when there are operating problems of the incineration such as heavy metal, dioxins, and so on. Next can impact the health of nearby residents, also can hinder the natural scenery. Next is the large-scale release of carbon dioxide, which will speed up the greenhouse effect. The last one, the cost of the waste treatment will be much higher, for around 8 times because of the higher toxic content. Next, we continue with our regulation in municipal solid waste. First, we have Environmental Quality Act 1974, Act 100 127, and we use section 21, 22, 24, 25, and 29. Second, we have Solid Waste and Public Cleansing Management Act 2007, National Strategic Plan for Solid Waste Management in Malaysia, NSP, and the last one, it can be related to environmental quality, which is Schedule Waste Regulation in 2005. For the last part in this literature review chapter, we have compliance and environmental safety, and we have 6 of it. The first one is the regulatory compliance, which is keep updated about the laws that control incinerator operations on a local, state, federal level, and respect operating guidelines and emission limitations to guarantee compliance to environmental regulation. Second is the emission monitoring and reporting. We put in place ongoing emission monitoring system to evaluate and document the amount of pollutants emitted during burning. Third, we have particulate matter control, which is utilize efficient particulate matter management devices, including scrubbers, baghouse, and electrostatic precipitators to capture and eliminate them before releasing the tiny particles into the atmosphere. Fourth is the combustion efficiency. In this combustion efficiency, we can operate incinerators at optimal condition to ensure complete combustion of waste materials and minimize the formation of pollutant. Fifth, health and safety measures, where we must put safety precautions in place to protect employees working incinerators from dangerous material exposure. The last is the EIA, which is Environmental Impact Assessment. In this EIA, we must conduct environmental impact evaluation before beginning incineration to determine the possible consequences on ecosystem, public health, and air quality.
As we can see, there are many sources of air pollutant emission, which is carbon monoxide, total organic carbon, polychlorinated dibenzoyl and furans, hydrogen chloride, sulfur oxides, nitrogen oxides, dust, and last, hydrogen iodide and iodine, hydrogen bromide and bromine. Next, air pollution control devices. For municipal solid waste incinerators, air pollution control systems are crucial to reducing the amount of hazardous pollutants released into the atmosphere. The purpose to eliminate hazardous gases, particulate matter, and acid gases that are released during the cremation procedure. Because of the advanced air pollution control technology used in modern MSW incinerators, the environmental effect of incineration has been greatly mitigated. For air pollution control devices, first, fabric filter baghouse. It is a useful technique for taking tiny particles out of a gas stream. It also important for the emissions of numerous hazardous and carcinogenic organic aerosols, heavy metals, and respirable particulates, which is PM2.5 and PM10. Second, electrostatic precipitators (ESP). It uses an electrostatic charge to remove particulate matter from the flue gas. They are effective for removing large particulate matter but may have limitations with fine particles. X. Wet scrubbers. It uses a liquid, usually water, to absorb and remove pollutants. It also effective for removing acid gases like sulfur dioxide and can capture some particulate matter. 4. Carbon absorption. Activated carbon absorbers capture volatile organic compounds, VOCs, and certain other pollutants. Activated carbon absorbers are effective for VOC control. Last, cyclones and inertial collectors. It extracts relatively big, massive particulate contaminants from a gas stream using inertial forces. Maximum angular velocity attained in the vertical flow zone inside the cyclone separator. For smaller particles are caught as they approach the collecting region at the outside wall of the device and rotate at an increasing speed.
Discussion for Task 1. Waste incineration is an effective method for reducing trash volume but raises environmental concerns due to pollutants emission. Air pollutants released during incineration process significant risk to both environment and human health. Despite challenges, Malaysia explored incineration as an alternative disposal method considering landfill limitation and environmental impact. Stringent emission regulation and advanced technologies are essential to mitigate environmental and health risks associated with waste incineration. Effective air pollution control devices such as fabric filter, electrostatic precipitator, wet scrubber, carbon absorption and cyclones play a crucial role in addressing emission. Achieving a balance between waste volume reduction and minimizing environmental impacts requires continuous improvement, exploration of alternative technologies, and public engagement. Emphasizing ongoing advancement in air pollution control devices is critical for achieving a harmonious equilibrium between waste management, efficiency, and environmental stewardship.
For task 2, we use ToxFlame software for conducting the data.
Let's we continue our presentation with the top flap. What is top flap? Top flap is an analytical model that describes the atmospheric dispersion of inert gases. It is based on a unique general solution to the diffusion equation which represents instantaneous, variable, and infinite duration releases. It computes the concentration field at predetermined periods, the highest concentration at each location, and the average concentration during a fixed time interval.
The result: for constant data of wind speed which is 2.5 meter per second, ambient temperature 12 degrees Celsius and missing height about 400 meter, the place that has been selected or determined based on ToxFlame is an industrial area where there are many factories that release their factory fumes located at Monza MB, Italy.
Analysis. The figure is show the graph for wind speed versus concentration. From the graph, we can identify that when the wind speed is increasing in a very stable condition, the concentration will be decreased due to the constant distance of pollution spread, temperature, and mixing height. For the second variable, which is temperature, the figure shows the temperature versus concentration graph. From the graph, we can identify that when the temperature is increasing in a very stable condition, the concentration will remain the same due to constant distance of pollution spread, constant wind speed, and height. For the third variable, which is mixing height, the figure shows the mixing height versus concentration graph. From the graph, we can identify that when the mixing height is increasing in a very stable condition, The concentration will decrease due to the constant distance of pollution spread, constant wind speed, and different temperature at certain height. Discussion for the second task. Task plan. An advanced analytical model designed for inert gas depression for instantaneous, variable, and infinite duration release. Outputs. It provides concentration field, peak concentration, and average concentration over fixed time interval. Influence of atmospheric stability, wind speed, temperature, and mixing height are variable influencing pollutant distribution dynamics. Very stable condition. Low wind speed and temperature inversions restrict particle air movement, leading to localized pollutant accumulation. Health and environmental risks. Stagnant air increase pollutants percentage, contributing to increased risk in stable atmospheric conditions. Temperature inversions. Formation of inversions layer traps pollutants near the surface, intensifying air quality issues. Missing height constraints. Limited turbulence in stable conditions result in a lower mixing height, concentrating pollutants closer to the ground. Management strategies. Understanding this factor is crucial for implementing effective pollution management strategies. Mitigation measure. Target emissions control. Targeted emission controls, regulator measure, and urban planning consideration are essential for addressing challenges in stable atmospheric conditions. Environmental impact. Comprehensive strategies are needed to mitigate adverse adverse impact on human health and the broader ecosystem. As the conclusion for the both tasks, waste incineration in Malaysia address recycling challenges, but it raises environmental concern. Malaysian proactive measures, including robust regulation and modernization efforts, highlight a commitment to sustainable waste management. Advanced technologies like ToxPlan demonstrate a focus on understanding and mitigating pollution impact. Balancing waste management efficiency with environmental stewardship requires active public engagement and collaboration. Overall, a comprehensive approach integrated technology, regulation, and public involvement is essential to minimize adverse effects of waste incineration on the environment and human health in Malaysia.